In this video, I'm going to be teaching you about reliability, and specifically reliability in a scientific experiment. In science, reliability is talking about a measure of how consistent your results are. The more consistent the results are, the better your reliability is. So if we have a look at this diagram, okay, if all of the arrows that are aiming at this target are not around each other, then it's not reliable, okay? It is, the results are not consistent, therefore they are not reliable. You cannot rely on the data that you have collected because it's almost random, the results that you're getting. So you can't rely on them. In this case, in the second case, well, you can rely on your results. The results just aren't accurate. Accuracy is different, okay? Reliability is just talking about how consistent your results are. So the results here actually were very consistent. Now, they weren't accurate, they weren't true, but they were reliable. I kept getting the same thing. In the third example, okay, so you kind of have two clusters, but again, they're not consistent, right? It's not all in one neat cluster. It's not reliable. And finally, and this is certainly the ideal in scientific experiments, that you have accurate results, but that are also reliable, that they are consistent. So, in order to be able to test the reliability, you need to actually conduct repeated trials, multiple trials of the same experiment. Do the same experiment over and over again. That way you can see, is it reliable or is it not reliable? People often make the misconception, they have the misconception that if you increase the number of trials, that you will increase the reliability. And that is not the case. That doesn't happen. It is not true. Doing repeats allows you to test the reliability. If you haven't repeated the experiment, you don't know if it is reliable or if it is unreliable. In other words, the reliability cannot be determined. So how do you actually improve the reliability? Well, you need to change some way or how you are taking your measurements. Okay? And what that really comes down to is, if you have unreliable results, odds are you either haven't kept everything the same, or actually the independent variable that you right isn't the thing that's affecting the results. It's going to be something else. So, if we have a look at this experiment, what might be some issues with the reliability from this experiment? Well, having a look at this, I can't see that they've done any repeats. So no repeats, which means the reliability is unknown. Okay? I don't know what the reliability is because I haven't repeated it. Are there any other issues with the reliability? Well, that's kind of the main one. Right? But let's say that they did. Actually do this test multiple times. Okay, let's say that they did do the test multiple times, and what they found, right? So let's say they found for this water reading that, right? Let's say for water, we had that it was 21 centimeters for the first trial. Maybe it was 25 centimeters in the second. Okay, 28 centimeters in the third, and then back to 24 centimeters in the fourth trial. Right? They did repeats. That's good. But are these answers consistent? Well, not very consistent. Okay. Right, let's say that this was actually 34, right? Super inconsistent results. So this would be inconsistent results, which means the experiment is unreliable. And then we need to think to ourselves, well, why was it unreliable? Why did I get different results every time I did the trial? Why didn't I get consistent results? Why were things different? And then you start thinking about validity. Actually, did I control everything? Did I actually control everything? Oh, maybe I didn't. Maybe I didn't put the pot plant in the same spot every time. Maybe it was actually in a bit too much shade at the start, and I put it in more sunlight later on. So reliability is all about the consistency of results. Okay, you need to do repeats. You need to do repeats to be able to test the reliability. And in order to improve the reliability, you need to change the experiment in some way. Okay, if you don't do any repeats, you don't know if it's reliable or not. You have to do repeats.